this fall, we started our first class at a school that we created in Chattanooga, Tennessee called Center. And the school is made up of people who are learning to be designers. They don't really know much about design coming in. It's a 2-year program. And the way the school works is every 3 weeks, they start a new course. You take one course at a time. It goes for 8 hours a day, 5 days a week, 3 weeks. The first week involves a industry expert giving an introduction to a topic. The second week, and then 3 days of independent study. And then the next 2 weeks, the second week and the third week, the students actually work on group projects with 6 students. And they are, those projects last for 12 to 16 weeks. So they're very intense projects. And so in October, we started the first class's Introduction to UX. They decided that I was the best person to teach that for some reason. They couldn't find anyone else who was available, so there I was. Taught the course. They did their independent study on what is user experience. And then into the project they go. And the project that they're doing, most of the projects that they'll get in their 2 years, they'll do 5 to 8 of these, will come from companies. But the first project comes from the school, and it's supposed to be something that the students will use pretty much all the time. And the reason is we want them to design something and then suffer with it. And so, because how best to learn the effects of design than to have to use something that was poorly designed, especially if you were the one who poorly designed it. So we want them to have that experience. And so that's the approach that we are taking with this. And the first project, all the projects are assigned because we're trying to simulate real-world stuff. So we don't let the students pick projects because that's not the real world. You don't get to go to work and pick what you work on. You get assigned something. So the projects are assigned. So the project we've assigned for our first class, for their first project, is a resource gathering tool for their independent study work. It's basically, the way we imagine it, is it feels a lot like Reddit or Hacker News. One of these things where you post links to things that are useful, and then you can comment on those links, and you can upvote the ones that you like the best. You can upvote the comments and that seem most reasonable. And the idea is that we're going to actually open this to the whole community so people can see what the students can do, and the students can see how people use their stuff, and it's just going to work. And that's the first project. So they start in on the design of the first project. It's called Alicorn, by the way, A-L-I-C-O-R-N. That turns out, I did not know this until I met our students, to be the physiological name for the horn on a unicorn. The unicorn being the mascot of our school. So that's what they decide to do it. And the first thing they run into is, well, if someone's going to post something to this, we have to know who they are. If they're going to comment, we have to know if they should be able to comment. And suddenly, we are in the middle of dealing with authentication. Their first designs had a login button and a new user button, and they had to deal with this from the very beginning. And questions start to come up. As they're working on the designs, there are all these questions about what does the user have access to? I mean, we need to know something about who this person is. We need to know if they are allowed to post new resources or comments or upvotes on things. We need to figure out if they have permission to be able to upvote a second time for a comment, or should we prevent them and therefore have to keep track of which comments have been upvoted by which people? And where do we send any notifications if somebody puts a comment in or replies to something? How do they get the notifications for that? Or if someone is behaving badly, do we kick them off? What's the issue there? Suddenly we are in the middle of all of this, and the students are realizing within the first 2 weeks of their design that they have to know who the users are. They actually have to know who they are. And this took me by surprise. I'm not exactly sure why it took me by surprise. I should have expected it. After all, we log into things all day long. The National Institutes of Standards and Technologies did a study a few years back. They had government employees keep a diary of their days, and make note every time they had to tell a computer who they were. And the average government employee does it 23 times a day. Let me restate that. The average government employee reports and acknowledges that they do it 23 times a day. There are probably way more times where they don't even realize they are authenticated. Badging into the building. Putting their credit card into a gas pump. But they are doing that all the time. We authenticate all the time. And every system has some sort of authentication feature. You can't go into anything. So it's probably the one thing that everybody in this room's work has in common. Right? That one thing is it. And if we look real close, they all look the same, right? They all basically are the same. I mean, sometimes we dress them up with David Attenborough, but for the most part, they always look the same. Is that because that's the best way to do it? No, it's because we are creatures of copying what other people do, thinking that they figured out what the best way to do it was. And so here we are, just copying and copying and copying without knowing what the best thing to do is. But here was the thing. Here we were in the second week of the course. We've been working on this project now for 5 years, this school. We have designed every moment that the students will experience. And nowhere in the 30-course curriculum that we put together did we put in anything about authentication. Not one moment. And it's not surprising that I overlooked this, because I spend my weeks, when I'm not at the school and not here at my office in Boston, I spend my weeks going to conferences. I go to 40-some-odd conferences a year. I've been doing that now since the 80s. I have never been in a session on the UX of authentication at a conference. It's not something we talk about. Yet it's in everything we design. And it's really part of the culture that we have created. It's part of every online experience. And we are not talking about it, and we're not teaching it. And so started to think about, okay, what do we need to do to get authentication into the conversation? To do that, we sort of have to step back and figure out why we do it at all. It turns out that authentication is actually a bundle of things that we do all at the same time. And maybe we shouldn't be doing it all at the same time. There are actually separate things that are supposed to happen. Turns out these three things are, first, identifying, are you, who are you? Do I know you in some way? Authenticating, which says, are you who you say you are? And authorizing. Do you have permission to do the thing you want to do? And it turns out that these three things are quite separate. Yet, we often treat them as if they are interchangeable. And that sign-in screen could be doing any one of these or any combination of them at any given time. Yet, they actually are performing very different acts. And it turns out that in well-designed systems, we separate them out. But in poorly designed systems, we bundle them all up. And they make things way more complicated for us. And this has the effect of being part of the undercurrent, right? Authentication, signing into a system, is an enabling task. It is something that we have to do the other thing we actually want to do, right? We log in to check our mail, except when we're in France. We log in to buy something so that we can use our stored credit card. We log in to post something on the shared resource collector, whatever it is, right? We do that. We didn't wake up in the morning saying, oh, today's going to be a great day. We're going to get to log in 23 times. Going to beat yesterday's record. Yay. Right? We say, okay, we have to do this. And sometimes we have to do it multiple times. Sometimes the session times out and we have to do it again. Or we leave and we have to come back and we have to do it again. And it's all about enabling the thing we want to do under this notion that we can't be trusted until somehow our identity has been established, we've been authenticated to say who we are, and we are authorized for the transactions that we need to perform. The thing is that when we just copy from one place to another, we're imitating. We're not really designing. We're not making decisions, is this the best experience? Design, in essence, is the rendering of intention. What's our intention? And the thing about signing into something is that, in essence, we've created a burden. And sometimes we make that burden really hard. We make it really difficult for our users. And so, how do we mitigate that burden? Because it's really a problem. The thing is that security is, in essence, what I refer to as selective usability. We want the people who should get access to the target assets, we want them to have complete access and to not be burdened at all. We want them to have a very smooth, easy to use access to that. But for the people who shouldn't, the bad actors, those people we want to prevent. We want to actually make it unusable for them. So we're actually trying to distinguish this notion between making something usable and making something unusable. This building has little pull boxes that you pull when there's a fire. And those pull boxes and the smoke detectors in the ceiling are all connected to a processor that lives in a box that is actually by the front door. That box by the front door is called an enunciator. And the enunciator, its job is to be the connection between the fire department and the building. So if somebody pulls that box, or if the smoke detectors detect something they don't like, they contact the enunciator contacts the fire department. when the fire department gets here, they can look at the annunciator and it will tell them what part of the building the issue has been reported. And they can go straight there. The annunciator also is sort of the control panel for the system. So when there's maintenance in the building, the maintenance engineers use the annunciator to sort of say, okay, we've installed new smoke detectors, we've installed new pole boxes. And years ago, I did usability testing on annunciators. And it was one of the strangest set of usability tests we ever did, because our job was to make it selectively usable. The only people who are allowed to use it are the fire department and the maintenance engineers. The maintenance engineers work for an authorized company. They don't work for the building. They work for an authorized company that installs these things. And the fire department is the fire department. Now, the fire department has to be able to use these things with fire gloves on. Because the first thing they do when they come into a building is they turn off the alarms. Seems unusual, but when you're trying to actually deal with a burning building, having a blaring alarm going at the same time is actually really annoying. Last thing you want to do is annoy a fireman. So they turn off the alarms. But the other thing is that the maintenance people need access to this. However, people who work for the building often think they're being clever and want to make adjustments, particularly if there's something like a faulty alarm and that keeps going off. They want to just go and shut it off on their own. And that is actually illegal. So we had to design the fire control annunciators to not work for anybody but the fire department or the maintenance engineers. And we actually did create usability tests that we would bring in random people, and if they could use the design, we had to change it until they couldn't. And that was fascinating, right? But that sort of hammered home this notion of, are you supposed to be using it? Now, those people were being authorized to use it or not use it by what they knew. And so just their knowledge would work. And if you want, later I can explain the crazy of how we got to that point. But it was a real interesting example to me of just how important this security stuff can be. But it's not just because, you know, people break into a server and next thing you know you've got a president you don't want. There's really important stuff too. A few years back, we did some work on an e-commerce site. And the e-commerce site was losing customers because they couldn't remember the email address and password combination that they had created in the system. And part of the problem was that we were in a usability test lab, and they weren't using their own computer. And had they been at home, their computer probably would have logged them in because they had a cookie set in the computer to say who they were, and therefore they didn't have to put in their username or password, and the system just recognized who they were. But because they were on our machine in our lab, they kept failing. They couldn't remember which username, which password they went with which. And the average person now has 5 different email addresses associated with them. They get a new one every 3 years. And oftentimes, people cannot remember which email address and which password they created an account with. And they go through these hoops of trying to always use the same password, or they have some system for which password they use. And when that fails, the system requires them to put in a new password, and they try and write it down someplace, and they forget it, and there are all these problems. And we kept seeing in the usability lab this failure to complete the transaction. They would buy stuff, they would put it in their shopping cart, they'd press the button to purchase, it would say, okay, now you got to log into your account. And they'd say, we can't log into our account. And they failed. And so we asked the company that we were working for, we said, just out of curiosity, how many people get the error message that says bad password? And they actually didn't know the answer to that. Right? Because that's not something anybody logs. That's not in your analytics. It's not a default package. You have to count that explicitly. And so we said, okay, well, how many people go to the reset passwords page? And they said, well, nobody. I said, what do you mean nobody? We just sat through 3 usability tests, and 3 out of 3 people did it. So we know at least 3 people did it. They said, no, we looked in the analytics. It's got 0 for that page. I said, go look at the page. And they did. And sure enough, no one had ever put the code in to actually count the page in the analytics. Right? So they put the code in to count the page, and suddenly it becomes the most popular page on the site. It's more popular than the home page. So we then asked them another question. We said, okay, for everybody who visits the reset password page, how many of them actually log in and complete their transaction? And they went and looked, and they said, it's only about 10%. Now, we were brought in originally because they were feeling like people were, they were losing people in their checkout process. And they were worried because they were losing 2% of people in their checkout process. But now they're losing 90% of people on their reset password page. So there's a different problem here. So we asked them to add up the shopping carts of the people who abandoned their password. And it came out to a nice round number of $300 million a year.
Wow.
Turned out it was not hard to suggest that they put into play a project they already had on the books called Guest Checkout. And when they added Guest Checkout, they increased their revenue that year by $300 million. So authentication has a bottom line issue too. Now the thing is that there are these people in companies whose job it is to wear the tinfoil hats. And the tinfoil hat people, they make sure that people are always following procedures. This is a paper that came out just a few weeks ago about how healthcare workers regularly invent workarounds to bypass their health system security because the alternative is it slows them down so much they are afraid they will kill a patient. This is the burden we are putting on people with our security. And we could be losing lots of money, we could be losing people's lives, and apparently we can lose the Republic. So, this turns out to be a big deal. And it turns out there's been a lot of research on this. One of my favorite papers is this one, and all the work done by this woman, Angela Sass, who is out of the University College of London. She's done some amazing work on something known as a compliance budget. And the compliance budget is this basic idea that we, as people, have a certain amount of tolerance that we budget up for being a good citizen and a good actor and following through on the stuff. But at some point, it just exhausts us. I mean, 23 times a day, it exhausts us. And we start to create bypasses in order to get past the security. And this is a design problem. We have created this through bad design. And it's time that we now start to take back over and render the intention that we want. Let's talk for a second about Amazon. Amazon has this very cool feature called OneClick. And OneClick is fascinating to me because it is probably the biggest contributor to their sales, right? The ability to just find a product, click the button, and that's it. It's ordered, and a couple days later, you have it. Right? It's an incredibly contagious thing. But the design of OneClick is incredibly brilliant and something that we don't really ever talk about. To understand how OneClick works from a design standpoint, you have to go back very much to creating the account. So the user creates their account. And what they're doing at that point is they're establishing their identity. So that's identifying. Right? And then the next thing that they do is they store their passwords, or their payment instrument. They store, the credit card or PayPal or however they're going to pay. That gets put into the account information. That's authorizing. Now here's the thing. These don't necessarily happen on the same day. In fact, they can happen months apart. Amazon has broken this up into little chunks. So you create an account the first time you want to purchase, but you don't have to save your credit card until you trust them. And then, once you trust them, you put in a transaction, you can say, save this for future. Now you've saved a payment instrument, and you've used the payment instrument. That, for Amazon, is huge. Because if you've used an instrument and nobody complained, that's a signal. So they take that signal. And then, at some other time, you enable OneClick. It's a separate act, and most people forget that you had to enable it. They also forget that it's enabled per device. So if you use Amazon on your phone, you have to enable it for your phone separately from enabling it from your PC. And that's because it drops a cookie. Which, by the way, drops a cookie would make an excellent band name. Just saying. Okay? And dropping a cookie is actually identifying and authorizing. The other thing you do when you establish your OneClick is you have to put in an address to say where you're going to ship it. And at this point, they may actually have you reestablish your credit card. So they'll have you put in your credit card information a second time, because that way someone can't get into your account and use a card that was already stored. You have to re-verify it. They actually, in the old days, they would just ask you for it again without telling you why they wanted it a second time, and people were like, I've already told you my credit card. This is stupid. But now they actually say, we would like you to retype your credit card to make sure you are who you say you are. And that's because you physically have the card. So they will do that. And again, these things can happen months apart, and then the fourth step is you get the product page with the button enabled. And again, months later, you have the OneClick. Many of you who have OneClick enabled probably don't remember going through those first 3 steps. They happened so long ago. And finally, when the order is placed, they do an authentication, an identity check, and an authorization, all at the same time. They look at the cookie on the machine, they make sure it matches with the credit card, it's going to the address that you said it was going to go to. If you try and change the address, they won't let you use OneClick. Right? You'll have to now go through another authentication process. It's absolutely brilliant, it's absolutely seamless, it's completely burdenless. It works 99% of the time, and it's intentionally designed. We need to be designing intentionally like that. Because here's the deal. If it's not usable, it's not secure. When you talk to the tin hat people in your trust and fraud security department, you just have to keep saying that over and over and over again. If it's not usable, it's not secure. If it's not usable, they will start putting post-it notes with their passwords on their computer. If it's not usable, they will use the same password everywhere. They will start to hack around it because of the compliance budget. That is all we can do. If it's not usable, it's not secure. So, we need to understand how to design for this. And this brings me back to the students, because here they are in their 3rd week, and we're now thinking about this. Do they need to identify? Do they need to authorize? Do they need to authenticate? What is it that they need? It turns out for something like Alicorn, it's mostly identify. That's the thing that is most important, is the ability to make sure that we know who that person is. We don't actually care that they're the real person. And if you want to understand the difference between authenticating and identifying, you only have to look at Twitter. Twitter has both capabilities. Most of us are only identified. I can create an account and call myself Donald Trump, and they won't stop me. And I can post things with a picture of Donald Trump, and the whole thing is fine. And I can say all of the crazy things that I want, and no one will be able to tell me from Donald Trump. Right? But if you ever look at a Twitter profile, occasionally you will see a little blue check mark. And to get that blue check mark, they actually authenticate you. They require that you send in 2 pieces of identification, and then they actually do a background check, and they actually send something to you at an address, and you have to respond with the code that's on that address to make sure that you are who you are and that that identification is legitimate. They go through a lot of effort for that little blue check mark. But they don't do that for everybody because there's a very high cost to authenticate everybody. So most people don't have that. So most of the people on Twitter are not authenticated. They're purely identified with a unique identifier. And that's all identification is, right? Identifying is, in fact, just a unique identifier. It's like a username or a customer number. In fact, in the old days, when I first started using computers, it was not unusual for the service that you were using to assign your user ID. They would tell you what your access number was. I remember schools would give you a login code, and you didn't get to choose your own username. You didn't get to choose your password. Those were assigned items to guarantee uniqueness. And so an identifier just brings you back to a unique individual. But it doesn't say who you are. It doesn't tell anybody who it is. Authentication, it turns out, is establishing that identity is matching a specific person. And we don't need that often. For instance, when you book an airline ticket, you actually don't need to authenticate the passenger. When the ticket is created, you put in information that gets authenticated at the airport by the TSA. But anybody can buy the ticket. The airline is perfectly happy to sell that ticket to just anybody. But to get through security, you have to then authenticate. To check your bag, you have to authenticate. But until that moment, you just establish identity. And again, this is a really important subtle distinction because our students don't need to authenticate our users. We don't have a system that requires that. But we do need to establish identity. And so the question is, what do we really need to know about this person? Do we need their actual name, for example? Do we need to know their first name separate from their last name? Or do we need a formal name versus a nickname? Do we have a way for them to change their name in case they get married or they are going through a transgender process or any of the other number of ways or reasons that people change their name? Running from debtors. So do we, spouses, yeah. Running from spouses.
That new TV show, Hunted, premiering.
Huh?
That new TV show, Hunted, where police are going to hunt contestants.
Oh, people are hunting contestants on a TV show?
Yeah, it's premiering this weekend.
That's exciting. Huh. You know, the difference between science fiction and reality gets fuzzier every day. I am pretty sure there was a Sylvester Stallone movie about this at one point. And then there's authorization. Authorization just says, you have permission to do this. So our students, when they're creating Alicorn, they want to authorize people to be able to upvote, to put in comments, to be able to reply to those comments. Who is authorized to delete a post? Right? So we have to create a set of business rules around authorization that are there. So all of these things have to be put into play. All these things have to exist. And these are details that escape a lot of design, but it turns out the minute we get it wrong, we've created that burden that makes it impossible. Anybody who shares a Google Doc knows this problem. Because you never have the permissions you want. I am convinced that if the team that the team that makes the Google Docs also makes the self-driving cars, passengers will have to ask 3 times to get into the car. The first 2 times they'll just say, you don't have permission. If the people who make Google Drive make the self-driving cars, then I'll never be able to find the car once I park it somewhere. If the people who make Google Hangouts create the self-driving car, I'll never know how to start it or stop it. If the people who make Google Mail make the self-driving car, every time I get in it, it'll have a slightly different interface and I won't know how to use it. These are the things that keep me up at night. So let's talk about establishing identity.
first word?
No, it's just that. It's one word, all lowercase, 4 words, all uppercase.
Is it 1 word or 4 words?
4 words, all lowercase, but it's 1 word, all lowercase.
F-O-U-R-W-O-R-D-S, all caps.
No, it's 1 word, all lowercase. It's like any other Wi-Fi password.
Okay, Jimmy, how many words are there?
It's 1 word.
You said there were 4 words!
It's 4 words.
I'm gonna grab that router and just beat you to death.
Rocket Jump 5G. No, it's 4 words, all uppercase. Not words, word. It's 4 words, all uppercase, 1 word, all lowercase.
I'm just gonna jerk off later.
Okay.
Are those your students?
I would love it.
He must work in IT.
So, the what we do to our users is just cruel. And the establishment of these systems almost never actually protects the security of them. Because in fact, if you look at all the major break-ins that have happened, none of them have happened because someone figured out someone's password. They happen because of an SQL injection. They happen because of someone intercepting a piece of information. The most common cause these days is some sort of social engineering. Phishing is probably the most common cause right now. There's the DNC, the Democratic National Committee, Congressional Committee servers were hacked into because an intern accidentally clicked on a link and logged into a website thinking that she was logging into her Google account and gave up her Google Mail password. It's not because people are breaking into email servers. That actually happens very irregularly. In fact, there's no evidence that the email server in the Clinton administration was broken into at all. But while she was there, there is lots of evidence, and it's been publicly announced, that the State Department servers were broken into by both the Russians and the Chinese more than 7 times while she was in the State Department. And it wasn't just her. They were broken into while Colin Powell was in the State Department too, which he also used a private email system, as did the Bushes, as does the Trump organization. So this is not uncommon. And in fact, oh, by the way, why do people at the State Department use a private email server? They use a private email server because it's impossible to print email from the State Department servers because it's too complicated a process to log in, find a printer, and make it work. So what do people do? They send the information to their private Gmail account. Everybody in government has a Gmail account. They just don't say it out loud. So, yes, she had a server in her basement. By the way, do you know where your server is? Just out of curiosity, because it could be in her basement.
I thought it was in a pizza parlor.
So, we make people jump through hoops to create accounts to make them secure. United just announced that they have instituted two-factor authentication. And the two-factor authentication is you have to make your password more secure, and they've created this crazy new password recipe. And then after you do that, you have to answer security questions. Oh no, they are not just any security questions. They are a list of United-created security questions. And because they don't trust you with the answer, they give you a list of answers to choose from for each question. You can pick your favorite pizza topping, which includes such wonders as mashed potato, za'atar, giardiniera, which I thought was a disease. This, by the way, is not two-factor authentication. This is one-factor authentication done twice. A security question is just a stupid password a second time. It's something that you have to memorize. And yes, we all remember our first girlfriend's favorite dog's cocktail. Two-factor authentication is actually something you know, like a password, something you have, like a key or a device, or something you are, like your fingerprint. Biometrics, we call it. Or, as it's otherwise known, a password which, once broken, can't actually be changed. And so, two-factor authentication is some combination of the two of these. And these days, you've probably experienced this in some form. When you have to enter the physical number that's on the back of the card of your credit card, unless it's an American Express card, at which point it's a 4-digit number on the front of the card. The reason they have you do that is because if someone went and made an imprint of the raised numbers on the card, that number would not show up. So they have to physically have the card to do that. If they combine that with something you know, like your password or the last 4 digits of your Social Security number, they now have two-factor authentication. And Apple Pay will work with a thumbprint on your phone, but you also have to have the phone. So it's something you have and something you are. And so those things authorize the transaction and can actually make it work. So that's what two-factor authentication is, or as Dan Kaminsky says, it's something you've forgotten and something you've lost. And two-factor authentication can be really effective if you can make the second factor work. And the problem is that for most of our systems, the second factor is not something easily accessible. We can drop a cookie on a machine. That's how Amazon does two-factor authentication for the OneClick. But it's very hard to do two-factor authentication for just common everyday usage because we don't have a physical thing that we already know about to verify against. So this is why they often send you a 4-digit code, or they make you click through to an email account and then click on a link. These sorts of things are the types of elements that get you there. And coming up with better ways to initiate the two-factor communication will make us a much more secure, better activity, and is way better an investment than spending a lot of time helping people come up with a more secure password by making it stronger by adding more characters that they can't remember. And so that gets back to this whole idea of password recipes. Password recipes are a huge disaster within the design space because people come, and if you watch people use accounts, the first thing they do is they try a password. They pay no attention to the password recipe. They type in the password they want to use and hope it takes. And then they'll pay attention to what the recipe is. And the recipe, you've seen the recipes that, must have at least 8 characters, must have one number, one lowercase character, must, contain at least 2 female characters. talk about something other than a man. And these recipes, really, they don't actually work. What causes people to figure out if they get access to a database is that the passwords are stored unencrypted. Or they're stored using an encryption algorithm, which is open source. And you can pretty much read anything in it and match against it. So people have created these large databases of common passwords encrypted in that form, and they just look for that sequence of characters in the encrypted form. The way you get around that is through salting the database. What that means is you actually create a second type of encryption. You basically combine this thing that the user doesn't know against the encrypted database. But even then, in salted databases, there was a recent break-in where the database was salted, but the assailants figured it out because the salt key was stored in the same database with each password. And so that's what happens. And it's mostly these types of things. TJX, the company that owns Marshalls and TJ Maxx and Bob's company, a few years ago they had millions of credit cards stolen. The way the millions of credit cards were stolen was people were parking vans outside their stores, connecting to the unprotected Wi-Fi that the point of sale used, and just reading the passwords or the credit card numbers and the data off of the thing as the cash registers were talking to the mothership. They just intercepted all the stuff. Cliff Stoll once said that most hackers are not computer geniuses. That if they were criminals in a neighborhood, they would basically walk from house to house trying every door until they found one that was unlocked and then robbed it.
Question. Because there were repeated reports that it was because TJX was storing credit card numbers on their servers.
No, they were reading Wi-Fi off of the. I mean, they were storing them on the server, but they didn't need access to the server. I mean, this is the key thing. You know, you can buy a Wi-Fi sniffer for $15 on the internet. In fact, you can get it with OneClick. So, the best thing to do the best thing we could do is to actually now eliminate passwords. We have all the pieces to do this. If you want to see it in play, you get a password manager, like 1Password or LastPass. And those password managers now have a password generation function. So for everything you log into, you create a unique password that pretty much only it knows. My password manager knows what my password to Twitter is. I don't know what my password to Twitter is. You could strap me down and try and waterboard me, but I could not reveal my password to Twitter because I have no idea what it is. My password manager knows, but it means I have to make sure I always have access to my password manager. But right now, that can be stored in hardware. So in fact, we can have that stored and encrypted in a salted database that only I can have access to. The same way that iMessage is currently stored and encrypted and only I have access to my messages. Apple doesn't even have access to them. So we have all the pieces. All the pieces are now there for us to lock it up. And here's the thing. The way the password managers work is when you come to a screen and you go to log in, you press a key sequence and it fills in your username and password for you. It does it by simulating someone typing it in. Right? It basically uses the same API as cut and paste. But that's a stupid API. What if we actually got smart and the operating systems built authentication in as a primal authentication function that allows anything to authenticate against anything? And suddenly what you do is you just, the API asks an API what my password is. I give the device permission to log me in using my single identifier, which can be my fingerprint, or it could be some other two-factor element. And suddenly I have secure connections everywhere, no one has access to this, and I am not burdened as a user to get into my things. And we're this far away from that. We just need standards to pull all that off. OpenID was supposed to do that, but it unfortunately was not designed. It was built by engineers, and as a result, it was not a pleasant experience. So that's creating the accounts, that's creating the items. But the next piece of this is that we have to deal with the experience outside the perimeter, right? If you think of security as you have outside the secure perimeter and inside the secure perimeter. When you're at the airport but you haven't gone through security yet, you're outside the secure perimeter. When you go through security, you're inside the secure perimeter. You've been authenticated to be there, right? What's the experience like outside the perimeter? A few weeks ago, I got a message from Yahoo informing me that my account, User Interface Engineering, the password on it had recently changed. I had no recollection that we had a User Interface Engineering account. Now, it may be real because I've been in business for 29 years. Yahoo's been in business almost as long. So in that period, sure, we could have created the account. Did I have the password? No. Did I change the password? No. Did I care? Not really. I mean, I don't know what it does, I don't know what it is, and I don't know if it's going to create some sort of problem. But someone changed the password and is now doing something with this. But look at this message, right? This is just a notification for your account safety. Okay. Have a great day.
Was it a phishing attempt?
I don't know what it was. If it's a phishing attempt, it's a pretty stupid phishing attempt because there's nothing for me to do to actually give them any useful information. No, I think this is actually Yahoo. This is why Yahoo is about to be no more.
It actually may have a tie into Verizon.
Yes, yes, it could be. Yeah. So it is crazy, but we do this all the time. BackCountry is a site that implemented the guest password feature that we had figured out could help people, and not guest password, but guest checkout, right? So BackCountry is a site that sells a lot of hiking, camping, outdoors type stuff, and recently someone was telling me about that they had received a gift over the holidays from BackCountry. And it was something that they appreciated the gesture, but they didn't need it, so they wanted to return it and exchange it potentially for something else or get a credit. And so they went to go refund, and there's a nice capability online to be able to refund gifts online. So they go and they get a screen that says, sign into your account. But they also have this feature here. It says return as a guest, but then it's currently unavailable. Well, this person had never bought from BackCountry. They never identified or authenticated with them, so they don't have an account. So now the system needs them to create an account. After futzing with this for a while, the person actually called the toll-free number, and the customer service person says, yes, it's easy. Just create yourself an account, and then you can return it. But I don't want an account, he says. Well, I'm sorry, but that's how the system works. And this back and forth went on for a little while, and finally he just said, can't you just give me the information and I just send it to you? And the customer support person, okay. And they did. But it was strange. The first reaction was, oh no, obviously you must create an account. It's like, that's the process, that's the procedure. And this sort of outside the perimeter wall is key. When I was back in Chattanooga with the students a couple weeks ago, they were showing me the designs. And my first question was, what's the experience of someone who has not logged into the system? And they all sort of looked at each other and went, I don't know. Because they had just assumed that you would automatically create an account upon arriving. But, you know, not everybody wants to get married on the first date. So how do we then create this experience that allows people to date for a while before they get married? And it turns out there's all sorts of things that the user can do on Alicorn. They can look at resources. They can read the comments. No, they can't add a comment. No, they can't add a resource. No, they can't upvote. But they can get a lot of value out of this system without ever logging in or authenticating. Why not let them do that? Why not let them have that experience? I was talking to a client the other day who was complaining that 99% of their users use it without ever creating an account or logging in, and they were completely frustrated. And I said, well, okay, but they're using it all the time. Are they getting value from it? Yes. Okay. Don't worry about it, right? Your issue isn't that they're not logging in. Your issue is you haven't given them a reason to log in. So creating that experience is absolutely key. Once we get on the inside of the perimeter, we have another set of issues to deal with. One of the things is that we need to think in terms of stages of security. You know, at the airport's a really interesting model because the airport is now constructed so that there are these big concrete pillars in front of the doors, these big planter-like things. And their entire purpose is to stop someone from driving a vehicle into the terminal. Okay, so that's one level of security, but it lets all the people through without any issue, right? It's a nice architectural barrier that lets people through, stops vehicles. We live in an age where we need to think about that. Then you get in, and there's TSA, which, for all its security theater, has an authentication stage and lets only certain people through. But then there's another set of security that most of us don't encounter, which is what you need to actually get a door open to go onto the tarmac or in the jetway or through the back hallways of the theater, of the airport. So there's all sorts of levels of security. And then there's an office where the captains and first officers go to do their flight prep. And that has security that only lets them in. And so there's all these distinct perimeters. And we can create an infinite number of perimeters. And that's exactly what Amazon does. When you have OneClick, you can order a $5,000 camera, and as long as you ship it to an address that you have already used and authorized on a machine that you have already authorized, you don't ever have to enter your password. You can buy hundreds of thousands of dollars of things without ever entering your password. But the moment you want to buy a gift card, for example, you are going to enter a password or a credit card number, something that will authenticate you. The moment you want to change an address, you're going to authenticate you. They have layers of it. And so the burden is distributed across the experience and not all packaged in one place. And we have to be thinking about that. And this comes down to our brand. It's really interesting because when we start to look at how you measure the effectiveness of a brand, one of the things that makes a brand effective is how people perceive you. And if you think of a brand as the sum of all the experiences that you have, we can measure it. And one of my favorite instruments to measure it is this thing called the Customer Engagement 11, put out by a group called Gallup. Gallup is the same people who do the political polls. And they've done a lot on this. And they have a series of 11 questions, which they've divided up into 5 categories. And each of these categories builds on each other. The lowest, least interesting category is loyalty. And this one has the things that we often see companies measuring, which is, are you satisfied with this? Would you do it again? And would you recommend it to a friend? And that promoter score question. But it's the next level up from this that actually gets interesting from the perspective of security, because that's the confidence layer. And the confidence layer starts with, I can trust these people. And so trust turns out to be key. Do I trust you to actually keep my information private? Do I trust you to actually keep it safe? And it turns out that the more hassle we have with security systems, the less people trust us. Company always delivers on what they promise. If they say, oh, it's easy to buy something from us, and then we put this hassle into play, suddenly that undermines our confidence. Similarly, this products company always treats me fairly, and if a problem arises, I can always count on this products company to reach a fair resolution. These are integrity questions. And those things are, again, wrapped up in things like what happens inside the security perimeter, what happens outside the security perimeter, how easy is it to change my password. So these are all the different things that come up when we start to think about this. And so if we really want to hit home, we've got an issue where if we build a poor security system, if we build a poor authentication system, something that's hard to use, we end up actually undermining our brand while at the same time making it less secure. Because if it's not usable, it's not secure. If for some reason you found this to be the least bit interesting, I'm going to be talking a bit more about this on our website at uie.com. If you work in design and we're not connected on LinkedIn, please, by all means, connect to me on LinkedIn. That's a great way to do that. You can use that email address, and sometimes you'll have to authenticate the transaction, claiming that you know the person by having that. And then finally, you can follow me on my unverified account on the Twitters at @JMSpool, where I tweet about design, design strategy, design education, and the amazing customer service habits of the airline industry. We have our UX immersion program we just announced, which you can find at uximmersion.com, which is which is going to be in Portland, May 1st through 3rd, and it's a fantastic program there. We have a whole session on UX metrics, a full-day workshop on UX metrics, a full-day workshop on lean UX, a full-day workshop on experience mapping, plus more. Go check that out. And we are starting a second cohort with 20 students in May in Chattanooga. So if you know someone who wants to become a UX designer, send them our way. You can find that out at centercenter.com. Or just reach out to me, and I'll be happy to talk to you about that. And that's what I came to talk to you about.
And then a group of us are taking Jared to dinner at Green Papaya afterwards in about half an hour. So if you want to talk to Jared, either now or over dinner, please join us.
So, if you didn't hear what Peter said, I'm going to take questions for how long?
Until you get bored.
No. We'll do it for like 10 minutes or 15 minutes. And then we're going to have a raffle. We're going to do the raffle now?
We can do it now.
Yeah, let's do it now. Then all the people who are just here for the raffle can leave.
Okay.
I never got a chance to enter that.
Oh, no. Did people not get a chance to enter the raffle?
Yeah, I did.
No?
Just for the raffle. They had their eyes open.
Here we go.
Nobody ever asked me about it.
Oh, no. Here we go. What are we giving away?
ACM membership.
Yeah.
This
It might have died. Oh, wait. Okay, no.
Does it work now?
No. Yes, I think it is.
Okay. I guess we need the level to come up a little.
This is the annual ACM membership, courtesy of GBC ACM.
Ah, a one-year membership. Okay. And it's going to Yvette Tenney.
Oh.
There we go. Front row. You doing something else?
Well, okay. So we also have a winner in the vitamin T raffle. Vitamin T has your email address and they will contact you. This is going to Maria Inez Garcia. She's here. Congratulations, Maria. And if I may be so bold, I want to see if I can sneak in one more announcement before.
Sure.
Okay.
Bold away.
World IA Day.
Okay, so real quick, February 18th, one full free day of a conference. We have 7 speakers, amazing speakers. World Information Architecture Day. It's a design conference, in case you don't know what information architecture is. Please go and register and come and free education. So, thank you.
All right, that's the extent of our announcements. We can switch to QA.
Okay. Let's pass the microphone around here.
We've got a microphone over there.
The microphone over there. Okay, so let's start in the back. There we go. Oh, you're welcome. Thank you for showing up. It's way more interesting when you guys come. Frankly, this is all stuff I've heard before, so
I was trying to tweet your old stuff at you, but then my phone died.
Oh, yeah. I like going through my tweets and learning what I talked about. Sometimes it's the only way I actually know what I said.
Mirroring. So I wanted to clarify something you said, which was the best thing to do is to eliminate passwords. I actually work for a company who does strong off for settings. And we hear a lot from our customers. We want to eliminate passwords, we want to do away with passwords. And a lot of the stuff you described is really, really familiar. But one of the things I heard you say was kind of having something like, moving away from passwords, moving towards something like Password Manager, which I guess would mean moving away from something you know to something you have, if the Password Manager lives in a device, correct?
Well, no. What you're doing is you're extending the security perimeter to a personal device, right? So the way to think of it is I still have multiple factors. I have to still have something I know to authenticate the Password Manager. But once I authenticate the Password Manager, it then can, or it can do something with something I am, right? So I can use my personal device and my thumbprint, and I'll get it. But the thumbprint thing is flawed. Just a few weeks ago, a 10-year-old, it was reported that a 10-year-old had ordered herself an extra set of Christmas gifts by taking her mother's phone and activating the thumbprint while her mother was sleeping, and then ordering a bunch of presents. So, yes, people say, wow, it's a smart kid until it's your kid, and then you're like, damn kid.
So, well, I guess then I'll go back. None of that quote you had that was really, really funny about something I forgot and something I lost.
Mm-hmm.
None of the factors are, 100% perfect.
Right.
It seems to me like the something you know factor is maybe the least perfect of all, because our memories are just flawed. So would you say, the two examples you gave, obviously passwords, people struggle with that, and then Q&A, security questions are terribly designed, and so on. So do we do away with that, or is there a better way to do the something you know, or you just move to the something you have, which you could lose?
Well, people have the ability to retain passwords, we've proven that, but we make them retain dozens of passwords. And we do stupid things like require that every 30 days they change their password and they're not allowed to use the other 5 passwords they have. And then we give them systems where they have to use 6 or 7 systems to get their job done. Each one has a different rotation schedule. And so they can't even synchronize the passwords across that. So what do? They start resorting to writing things down. And then as soon as they resort to writing things down, you've lost the game. So why not just bypass all of that? We already require people to have a badge. The badge could have some sort of technology in it to identify that we are in fact the owner of that badge. And it could use something that we know to access that badge, and we can keep that by itself secure, and then that gives us access to everything else. It is not a whole lot different than an RSA key, except that it's got a lot more logic to it, and unlike an RSA key, you can make it harder to crack. So I think that the pieces are all there. What isn't there are the standards. What we really, so right now, I can take my laptop and I can plug it in anywhere in the United States and it will draw the right amount of power and do the right amount of stuff. That's because we have a standard that wasn't designed for laptops. It was designed to pass electricity through, but it just happens to always work for my laptop, and it also works for my microwave oven, and it works for all the things. Even though none of those things were in play at that time. We can create a standard that is similar, that allows us to move past authentication data back and forth. But we have to have everybody agree on that. And that's the trick with standards, is getting that agreement. But I think we're very close, but right now a vendor wants to own it. And this is what OAuth is, right? OAuth is this capability of logging in with your Twitter password or logging in with your Facebook password, except for the problem is that I don't think I want Twitter or Facebook. They're not the people I really want to protect my passwords, because once they are hacked, and they will be hacked, everything I've logged into with that has been there. So we need something where I'm controlling my password. It is in my control. That's what OpenID was about. But OpenID required that every single one of us implement a server somewhere. The way they would implement it is you'd actually have to get a host and implement a server that's on the internet. But right now, you don't need to do that. We could actually build a device that you carry in your pocket or around your neck or on your wrist that actually does all of that for you. And if you want to see it in action, just go to Disney, because Disney built it with the Magic Band. They have identification, authentication, and authorization in one device, lets you do anything in the park. Lets you get into rides a little early, brings up your cash transactions, takes pictures of you wherever you are, does all the things, and it's a seamless experience, right? That's what we need for just, the real world. And really, the only thing that's preventing it at this point is standards. All the technology exists. It's all here. So. Oh, question over there, okay.
Yeah, so I guess you sort of touched on this a bit.
There's only one question. We'll just keep answering it over and over.
Yeah. So I was going to ask for something for like multi-user environments. So something like you mentioned with maybe a workstation in a doctor's office where there's not one single user. Do you think it's significantly harder to create a usable sort of authentication experience for that, or would it come down to something like a smart card, like you mentioned?
No, I don't think it's hard to create it at all. The multi-user thing is really just about proximity. And detecting proximity of radio devices is actually fairly easy right now. So I think that we can do that. One of the things that the study at Dartmouth found was that there's a system at a hospital that is used for signing death certificates. And they used biometrics to log in to sign the death certificate. For some reason, this hospital had only set up one doctor. So that doctor signed every death certificate in the hospital, whether that was their patient or not, which probably raised his malpractice insurance dramatically. That sort of thing is easy to fix. We can create identifying devices that tell that when we're nearby. My car knows how to do it. Right? I walk up to my car and it unlocks the door for me. It doesn't unlock the door for someone else. It does it because I have a radio transmitter in my body. And so that, and it's even smart enough to know that if I go into the door on the driver's side, to only unlock the driver's side door and not unlock the passenger side door in case there's an assailant who's trying to sneak in and carjack with me. So, I mean, we can do it. We have all the pieces. We're just not being smart about the design. This is where, as designers, we come in. And we have to ask the question, how can we approach this problem in a way that actually gives an intentional amount of burden to our users? Users don't mind a little bit of burden. I don't mind carrying the key in my pocket. That makes perfect sense to me. And it costs $400 to replace, so for some reason, I haven't lost it. So that I get too. But we can build that in and make that work.
Car insurance rates have gone down because of that.
Yes, right. Richard would like me to tell you that car insurance rates have gone down because of that. Not because he said it, but because insurance.
It's too hard to steal a car.
Yes, it makes it harder to steal a car, right? So we make things more secure, and at the same time, we improve the user experience for it. We're right here. Okay.
I just had a thought, but maybe this is a half-formed question about how do you get people to invest in your security when they don't have a stake in it? Just as a quick example, my company interacts with Boston Public Schools, and every once in a while they send me an email about a random moment in time survey where I have to report where I was at a certain time, what I was doing. And for that, I have to every time log into an account with one of those, recipe passwords that I never remember. And it's like, I don't care about this survey. I don't care about how secure their survey is. So what's my incentive for ever doing anything, instead of just I just don't
right, so that's
reset the password. I don't care about your security. I don't work for Boston Public Schools. I don't really care about, you having this data beyond my obligation. So how would you get people, incentivize people, not punitively, to invest in, your organization's security?
Well, first, the question is, what the hell are they securing? Why do they need to have security? Right? And why do they need to do it more than once? If they can drop a cookie on your machine, and as long as that cookie is present in the browser, you are known to that system. Do they really care? Does it somehow invalidate the survey? So what is the price? And so the issue isn't how do you incentivize users. The issue is how do you get your experience? Do you actually understand what your experience, the burden you are putting on users in your experience? And is that the intent? Is that your intent? Because for most design organizations, it is not their intention. But we slowly, the problem is that the way we get really bad authentication systems, really bad security systems, the user experiences that are bad for that, is we're boiling the frog, right? You put the frog in the frying pan, and if it's too hot, they just jump out. But if it's a cold pan, you just slowly turn up the heat. Not that I've ever done this, but it does taste a little like chicken. That act is we build these things on, and the next thing you know, it's like, well, why do you have a password? Well, everybody has a password. Well, why is it a hard password to remember? Because it's not secure to have a stupid password. Okay, it's not secure to have a stupid password, but why are we doing this? And what? You are a product owner on his product? This is going to get good. So can we give her a microphone? Okay, please, go ahead. Yes.
What we wanted to do was the email. What happens is that you have a lot of people across the country who are doing things, who are providing services that the organizations want to send claims to Medicaid. So you have random moment time study as a way to get that data. We have this problem, it's a huge problem. A lot of people only get moments once every 6 months, maybe none. And so the passwords are impossible to read. What we wanted to do is that they get the notification that they need to go and log in on an email. And we wanted to put the authentication in the link within the email. But our team, and we thought that would work really well. They just click on the link. That link is unique to them. It brings them right in. They answer the couple of questions. That's their moment that we can put the claim in and say this is what we did. So the 10 people refuse to allow that.
Yeah, that I don't blame them, right? Because anybody can receive the email and click on the link. So that doesn't help you at all. What you need to do is separate the authentication. But he created an account at some point and established that password. And he probably did it on the same computer he always uses. So why not drop a cookie that, when the cookie is present, says this person is authenticated? I mean, if it's good enough for Amazon for a $5,000 purchase with OneClick, why is it not good enough for you? Right? And that's only one way you could solve the problem, right? You could solve the problem additionally by sending a separate identifier through a different medium. So when he gets the email message that says he has to do this, he gets a text message with a password, a 6-digit code. He enters the 6-digit code, it proves it's him, right? And there's about 6 different solutions that are just like that.
There was a lot of arguments about it, and the security people within the organization were very difficult to...
Right. And so guess what? It's not secure now, because he keeps it in a piece of paper in his wallet.
Again, it's not me anymore, it's somebody else is doing it now, but it was a huge amount of what you talked about before, which is everybody has to reset their password every time.
Right. Yes, right. So that's what all they're doing is they're now resetting their password every time, which pretty much allows anybody to phish the account. So you've created security theater. And I'm glad you're not there anymore. But this is why we need to have more discussion about design. The other day I was talking to someone from the U.S. Postal Service who was complaining that, he says, well, our problem is that we have people creating fake accounts all the time. And so here's how we fix that. We have a series of questions you have to answer to prove you are who you say you are. And because they're writing bots to do these things, we always rearrange the questions and change the wording. I'm like, you can't win that war. Right? Because there's 2 ways that they can beat that. First, they're going to build some sort of machine learning tool based on some open source machine learning library that they can download for free. That's just going to learn questions and answers and just keep trying millions of questions and answers until they get successes. If we can play Go, we can definitely solve this problem. And the second thing is that they're just going to hire people on the Amazon Turk, and for 5 cents a password, just have them randomly try things until they find one that works. This is the easiest thing. So both of these things are crazy. I'll be around for a few more questions if you want, but ladies and gentlemen, again, thank you very much for encouraging us.